Hello, welcome to my first Minecraft video. In this video I'm going to give a brief introduction to Redstone. In Minecraft, Redstone lets you do some pretty interesting things. In many ways, Redstone is sort of analogous to electricity. So, for example, what we're looking at here is a couple blocks. These brownish blocks here are actually called glowstones. So what a glowstone does is when it experiences a redstone current, it lights up. This is a button on this stone here, and this red uh, dust on the ground is called redstone wire. So this button will generate a pulse of, I guess, redstone current. So this button will generate a pulse of redstone current, and that pulse will be carried along this wire to this glowstone. This glowstone will turn on whenever this button is sending out current also, so they'll light up at the same time when you press the button. The button sends out redstone current for a second and then switches off. Another kind of input, instead of a button, you can use a lever, which you can simply switch on for an indefinite amount of time, and then when you're ready, you can switch it off again. Now, a better analogy, I think, than current is logic. In fact, logic isn't really even an analogy. Redstone current, redstone wire basically operates under principles of logic, such as uh, and, or, not. These sort of logical operators can describe redstone circuits. So whenever you have two redstone wires intersecting, what you essentially have is an OR gate. So what we have here is these two inputs, left and right, and these two inputs come here, they meet at this point, and then there's this output here. This is an OR gate because if input A or input B is on, the output will be on. So if I press this button, input A is on, the output is on. If I press this button, similarly, if I press them both at the same time, the bottom line is if either or both of them is active, then the output is active. Now the reason they all three light up whenever you press one of the buttons is that, so for example, when I pressed this button, redstone current came out here, went along. At this junction, it went to the output, and it also continued along and went into the second input. Now there's a way to change that behavior if you need to, and I'll talk about that a little bit later in this tutorial. Over here we have a NOT gate. And what that means is, very simply, this block right here, if there is no current coming in, then there will be current coming out. Now if I hop down here and switch this lever on, now there is current going in, and the inverter will output, the inverter's output will be off. So this is a little bit complicated just to have these two indicator lights for the state of this circuit, but it really comes down to this block right here, this block of stone with a redstone torch on the side of it. That's the inverter. Whatever is coming in here will be inverted coming out. This is another logical gate called an AND gate. What that means is that if the inputs are both off, or if only one input is on, the output will be off. The output will only be on if this input and this input are on. And this is a little bit cumbersome to construct, but essentially what you do is for these two inputs, there are two inverters. So whenever the input is off, coming out of here, because of this inverter, the redstone signal is on. If either of these is off, because this is an OR gate that's combining these two outputs, if either of these levers is off, this redstone here, this redstone wire, will be on. This redstone wire is going into another inverter, so if it's on coming in, it'll be off going out, and that's our output there is off. So if only one of them is on, this redstone wire is still on because the other input is sending out an on signal. But if we turn them both on, then neither one is sending out an on signal. This wire is off, and this inverter is then on, giving us the correct output. This is the most interesting circuit to me. This is a basic memory circuit. What it allows you to do is toggle it between two states, which it will then stay in until it receives input to switch into the alternate state. So right now, let's call this state B because the further glowstone is on. The real heart of this circuit is this square right here, this 3x3 square with two redstone inverters and this wire connecting them in this pattern. This circuit has two inputs and two outputs. These two squares, these two blocks with the redstone inverters, are the two inputs. So this button goes into one input, this button over here goes into the other input. What happens when, if I were to, for example, press this button here, redstone current would come along here, it would reach this inverter, and this redstone torch would go off. That would send an off signal along the redstone wire here to this redstone inverter, turning this redstone torch on, which would in turn turn this redstone wire on, and the circuit would be in a new state. Now I can press this button here. I have a shortcut button. When I press this button here, it will be equivalent to pressing this button, sending a pulse of redstone current into this inverter and turning this redstone torch off. So you can see what happens to the circuit when I press this button. And you can see the whole circuit has switched so that whereas previously this glowstone was on, now this glowstone is on. And pressing the button with the state, pressing the button corresponding to the state that the circuit is in doesn't have an effect. Only pressing the button corresponding to the alternate state has an effect, regardless of what state the circuit is in at any one time. Now, one of our last redstone topics here will be these redstone repeaters. They have a variety of functions, really. They'll repeat the redstone signal, as the name suggests, because it degrades as it travels. After about, I believe it's 15 blocks, a redstone circuit will degrade to nothingness. An on current, an on signal will degrade to off. You can use a redstone repeater to re-up the signal. But they have another function in the construction of logical circuits, and that is they only allow redstone current to pass in one direction. So you see these two redstone repeaters are oriented in an opposing fashion. they're facing opposite directions. So what each one of these does is, for example, if I press this button, redstone current comes out here. This redstone repeater repeats the redstone signal in this direction, and the signal goes to the block, the output glowstone. But when the signal tries to go this way, this redstone repeater doesn't allow it. This redstone repeater, since it's in the opposite direction, only allows signal to come from this side. If signal comes from here, it'll pass it along and it'll go to the output, but when it hits this one, it won't allow it to continue on to here. So we've changed the behavior of the OR gate to be a little more proper, really. The output reflects the state of the two inputs. If either or both of them is on, the output is on. But it does not allow one input to turn on the other input. And finally, in this redstone introduction, this is a way to manipulate minecart track. If you have a minecart track with a curve like this and two possible directions that it can take, you can use a lever or some other redstone input to switch the track between the two possible courses. So that's my Minecraft video. I hope it was helpful to you. Hope it taught you something useful about redstone. Little teaser, my next video I'm going to discuss how I used all of those components that we just talked about to create this train station. You press a button to select one of 4 tracks to go down, and it's pretty interesting, so I hope you check it out. Thanks a lot for watching.